Hello. Today we will explain a feature in our web application that allows the user to calculate pallets with one type of box. These calculations can be made individually, that means one by one, or from a list of specifications. The first step is to log in. We use our username and password. Next, we will click on the single boxes item in the pallet fill menu. Here we will see that we have two menus. One of them has the pallet constraints that we set up previously in the base section. Pallet constraints and base are the same thing, and they're basically pallets with constraints, with length constraints, width and height, and also weight. The SKUs, or boxes, are also in another list. We can pick from any one of these, which are also stored in the products section. Here, products boxes. So first, we will just create a simple specification in which we select a box from the list and just click on Add. So we have the constraint, here it's called tall, the box code, and we have 0 for the tie height and total number of boxes. Tie is also known as the number of boxes per layer. High is the number of layers per pallet, and the total is the multiplication of these two values. But since we don't have any idea how many boxes fit into the pallet, we just leave these values as 0. As for patterns, we have lengthwise, transversal, and mixed. Lengthwise is, as its name indicates, all the boxes face the length of the pallet. Transversal, the boxes are placed transversally on the pallet. And mixed is an arrangement that can combine the boxes either lengthwise or transversal to fit as many as possible. Once we do that, we can click on the Output tab, and we will calculate 3 pallets. One in which the boxes are placed lengthwise, the second one, they're transversal, and in the third one, they're optimized. In this case, since both the length and the width provided the maximum amount of boxes per pallet, the optimized pallet is either one. We see we have 3 results, and we have a tie, or number of cases per layer, of 6, number of layers of 5, and 6 times 5 is 30. We have a load length, width, and height, and a weight. In this case, is not including the pallet weight. Area efficiency, volume efficiency, and weight efficiency. Now we'll go back, and we can also calculate this same product, but specifying, as we mentioned before, the number of cases per layer, the number of layers, and the total. So we had seen before that we had 6 and 5 and 30. So let's now put one number that's lower, 5, 5, and 25. 5 times 5 is 25. Okay, we add the specification, and we calculate it. We see that we have a 5 by 5 pallet, and we see that one box is missing. Basically because it's the same arrangement as before, but with one box less. This kind of arrangement is useful, although this one is very inefficient. Look, it's just an efficiency of 70%. Sometimes the pallets will come from not exactly this one, but the pallets will come from manufacturing or primary transport with less boxes than they actually fit for one reason or another. So that's how you do it. You just specify the exact number of boxes per layer and the exact number of layers. In this window, we can also do a calculation with a list of specifications. We can load them from a file. The file that we'll be using is a comma-delimited file that we can generate with a spreadsheet, or we can generate with a text editor. Basically, the columns are the following. We have the pallet code. As we saw before, it's the same code here. It's the same name for the constraint. We have box code, which is the name of SKU, the code of the SKU, right? We have number of boxes per layer, or tie, the tie, number of boxes and number of layers, and the total number of boxes per pallet. We don't know the values, we just put 0. As for pallet default and pallet full, the pallet default is whether we will use these pallets directly for truck calculations. Pallet full means that we will not add more products to these pallets once they are in a truck. For example, let's say that the allowable height of the truck is 2 meters and the pallet is just 1.6 meters tall. We won't be using those 40 centimeters, that space of 40 centimeters to put more boxes on it. We'll just leave that space empty. Okay, so we have a file like this. We have it in comma-delimited format or CSV, and we can import it. So from here, we click on import specs. We look for the file. We open it, we load it, and we will see that it looks like in the spreadsheet. We have the pallet constraint, box code. In this case, there are different ones. We have zeros here, and we have all the patterns. That information for the patterns wasn't in the spreadsheet. It was because we had checked here all. So let's delete them again, right? Delete the specifications, and now we will load them just with the optimized or mixed pattern. So we import the specs again. We choose the file, load it, and we see that now only the 10 is here, which is the mixed one or the optimized one. We click on output to calculate, and we will see that for each box, we will obtain 1 pallet. You can scroll down and we see the drawings. In this case, the boxes are all yellow and they have the same dimensions. The only thing that differs between the boxes is the weight of the boxes, and you have the different SKU numbers. Now, with this result, you can generate a report. We select them all, and we click here on Export a Pallet Report. This will allow us to generate a report, a pallet report. Okay, in HTML format. We save it, and we can open it. When we open it, we see that for each configuration, we have the size of the box or shipper, we have the stack, we see the top-down view for each one. This can be printed or exported. We can print, you can save as a PDF, and in each PDF or each page, you have one specification. This is very useful for the warehouse and for trucking. Thank you.